In this video, we're going to work through some examples of the back side of the ternary compound worksheet. The first example we're going to do is from the name to the formula for zinc sulfate. One of the things that I notice when I look up zinc is that it's in the transition metal section, and I don't know what charge it's going to form because it's not in an A column. So I go to my oxidation state chart, which will show me the possible charges, and luckily it's a Zn with a 2 plus. There's only one option there, so Zn is simply a Zn with a 2 plus charge. Sulfate, I know I'm not going to look up sulfur because if it was sulfur, it would not be sulfate, it would be sulfide. All of these get their ending of the name changed to IDE when they're a single element from the periodic table. So when I see sulfate, that indicates to me I got to go to my polyatomic ion chart and I look it up, and it's an SO4 with a 2 minus charge. SO4 with a 2 minus, a 2 plus with a 2 minus, so those simply come together, ZnSO4. Let's take a look at letter F, aluminum hydroxide. So aluminum on the periodic table in column 3A becomes a 3 plus charge based off of the outer electrons. Hydroxide. Now, this one is one of the tricky polyatomic ions. What I have been saying is if we end in IDE, we know we must have been a single element from the periodic table because we changed fluorine to fluoride, chlorine to chloride, bromine to bromide, selenium to selenide, sulfur to sulfide. So almost all of these polyatomic ions end in something different than IDE. Notice ite, 8, 8, 8, 8, 8, 8, ite, 8. That's our clue to look on the back of the periodic table when it ends in that ATE or ITE, with the exception of two. One is hydroxide. I wish they would not have ended his name in IDE because it confuses students and thinks that that was an element from the periodic table. And the other one is cyanide ending in IDE. And it's one that makes you think that it came from the periodic table. And then finally, peroxide. We have three that end in IDE that almost trick us into thinking they came from an element on the periodic table. I wish they would have chosen other names, ending of the names for these instead of IDE. So those three we're going to have to remember. They are not straight elements from the periodic table, but instead we have to go to our polyatomic ion chart. So hydroxide is an OH with a minus. The OH 1 minus does not cancel the 3 plus. We need two more OHs with a 1 minus. OH minus, OH minus, OH minus. 1 Al with 3 OHs, and the rule for polyatomic ions is if you have more than one of them, you have to put in parentheses and then the number on the outside, Al, and then in parentheses OH with a 3. The next example, letter H, barium phosphate. Barium is in column 2A. It's a 2 plus, so barium with a 2 plus charge. Phosphate ending in ATE, indicating we're dealing with a polyatomic ion. Phosphate, PO4, with a 3 minus charge. So PO4 with a 3 minus. The 2 plus and the 3 minus do not cancel. So I put another Ba with a 2 plus. Now there's a 4 plus and a 3 minus. So I need another 3 minus. 3 minus 3 minus is a 6 minus. 2 plus 2 plus is a 4 plus. I need one more Ba. 2 plus 2 plus 2 plus, give me a 6 plus. 3 minus 3 minus. So this becomes 3 BAs. And there are 2 groups of PO4s. So we write a PO4, and because there's 2 groups of them, we have to put a 2 on the outside. Any instance that we have more than one polyatomic ion, we have to put it in parentheses. If we don't have more than one, we do not need to use parentheses. Let's look at a couple of names from the formulas. K is potassium. So we write potassium. And actually, before writing the names, I do also want you to put the ions down. So K, there are 2 of them. And when we go to the periodic table, we know that K is a 1 plus based off of being in column 1A. So K with a 1 plus, and there are 2 Ks with a 1 plus. And then SO4, recognizing that group of SO4s and looking on the chart, and it's a 2 minus, so that makes sense why it's K2SO4. 2 Ks with 1 SO4, not needing parentheses because there is only 1. Its name is simply potassium sulfate. Let's look at this one, Al. Al is in column 3A, so it forms a 3 plus based off of losing those 3 valence electrons. This grouping of NO3 is nitrate, and it's an NO3 with a 1 minus charge. So Al, I'd put A. NO3 with a 1 minus, and it's saying we have 3 groups of these NO3s, and that makes sense why we need those 3 groups, because the 1Al is a 3 plus, and this 1 NO3 is a 1 minus, 1 minus, 1 minus to get us to match. And its name is aluminum, and then the NO3 grouping is nitrate. Finally, the Ca, column 2A, so forming a 2 plus charge, and SO4 grouping sulfate, forming an 2 minus charge, so those cancel out, and we just simply have calcium sulfate. I hope this helps in understanding ternary compounds involving polyatomic ions, going from the names to the formulas, and also from the formulas to the names.